Everybody, welcome back to another fun and exciting pre-calculus class. Today we'll be continuing, actually finishing chapter number 11, and it's been a long chapter, but it's been short lessons, so lessons that hopefully you should have been able to digest. If you missed anything, make sure to go back and watch those videos again. We'll be doing lesson 8 and 9 in this video, and go ahead and open up your books to page 225. Page 225 is lesson number 8. And in lesson number 8, we talk about the distance. Distance is the shortest line between 2 points. Okay? So we're going to figure out different ways to calculate that, different ways to think through that. The first question that they give you, really, there's only one example in this lesson. So if you look down here at example number 1, or the example, find the distance from the line 2x plus y equals 4 to the point 11, 2. What are they asking you to do? That's important that you kind of understand that. Let's think through this. So, you've got your Cartesian plane, and you've got a point up here at 11, 2. So 11 over on the x, I'm not going to make it perfect, and 2 up on the y. Let's just say that it's over here somewhere, okay? That's the point. Now, this line is going some other direction. I'm not going to take the time to graph the line exactly, but I'll kind of get it close. For me, it's easier to graph when it's in the y-intercept form. So that would be y equals negative 2x plus 4. We know that it crosses the line at 4, so we'll put it right here somewhere. And then its slope is going to be negative 2, 1, so negative 2, 1, something like this. Our line is going to be going something like that. Again, I'm not making it perfect. Now, the question is, what is the distance from this line to this point? In other words, it wants to know, remember, the shortest distance between these 2 points right here is a straight line. So it wants to know what the distance of this line is. Now, there's a few ways that we could do it, right? We could kind of use trig here. In a way, if we had this intercept, we could count over, we could count up, and we could find using Pythagorean's theorem, we could find that. So that's one way we could do it. But we can also do it just using our algebra concepts that we've been using in this lesson to kind of figure this out. So that's what we're looking for. That's what we're doing here, finding the distance. So got your little graph, you got your little line on the graph, you got your little point on the graph. You need to find the distance of that line. So let's think through, what do we need? What are we missing? First of all, this is our original line, so let's find the perpendicular line, because that's the line that we need. That's what we're measuring right there, is the perpendicular line, and we don't even have it yet, okay? So let's go ahead and get it. So we'll take this 2x plus y equals 4. And we're going to do, this is the way I've been doing it. So we have an A point, the B point, the C point, and the M point. Okay? So what we need to do is we need to figure out what these are so that we can, go from there. We really don't even need to find the M, to be honest, because if we find the A and the B, the C is easy in that one, right? It's 4, the A is 2, and the B is 1. All we really need to find here is the A and the B, because we have that slope equals negative A over B. And as soon as we plug these two things in right here, we find that the slope is negative 2 over 1. All right, so we can put it down there, negative 2 over 1. Now, we didn't even really need to do that, because we know that from last lesson, we can just instantly switch these two things. We can switch our A and B. So this is the original over here, and this is going to be the new, or I'll call this the perpendicular. Okay, so this is the perp over here. So we have A equals, remember we're just switching the A and the B. So A is going to now equal 1. So B is going to equal 2. And our C is, we don't know that yet. This is really what's going to determine what our equation is. And then the new slope, and we can do that by just inverting that. So 1 over 2 positive 1 over 2. So the way that we do that is writing our new perpendicular equation. We're going to swap a and b, which is what we've done here. So now we have x. We change this sign. Remember, in perpendicular, we change that sign, minus 2y equals, this is what we don't know. This is the question mark. This is the c. Okay? So now we're going to take this point right here. Okay? This is, remember when we kind of did our little graph right here, we had a point up here. And then we had our little green line. This is the point. This is like the end point that we're looking for. We're looking for the stopping point, right? So this will tell us where the line kind of starts. So plug that into this equation and we get 11 minus 2 times 2 equals c. So this is going to give us our equation. So 11 minus 4 equals c, or 11 minus 4 is 7 equals c. So our c is 7. Okay, that's important. Now this is going to give us our equation right here. So this is our perpendicular equation. Now we're not done yet because we're not looking for the equation, but that's important. So let me kind of erase some of this other stuff so that we can just focus on this equation, because we're going to need this equation. Again, we're not done yet, but we'll kind of go ahead and get rid of some of this other stuff. Now, what else do we need? Okay, so we have the equation, right? We know where it starts. In other words, what we have right now is we have our two lines. So here's our x. We have this line. So that was the original equation right there. And then we have this new one. I'll color this one green because that's what I did it in the other one. So now we have this line. The other thing that we have, because of this point, the original point right here, we know where this one starts. Okay? What we don't know yet is, technically, we don't know where it stops. Okay? Now, we know where it stops theoretically, like in our mind, we know it stops on that line, but we don't know where it stops on the line. How are we going to figure this out? How are we going to figure out where this crosses? Do you remember how to find where things cross? Okay, so what we need to do a system of equations. When we do the system of equations for this green line and this purple line, we will find out this point right here where it crosses. Then once we find that out, this is going to be our 11, 2 up here. As soon as we get this, then we can plug into the distance formula, and then we can solve it out from there. But we're still missing a piece. We're still missing this point right here. How do we get that? We do a system of equations. What is our system of equations? It's this original right here, and then this new one. So 2x plus y equals 4. 2x plus y equals 4. And then our second equation here is going to be x minus 2y equals 7. Now, you can do it a number of different ways. I like elimination. The book shows you substitution. I'm going to do elimination. That way you can kind of see this process as well. Obviously, we can't eliminate anything right now because if we add these together, I'm going to get 3x and I'm going to get a negative 1y. So that's not going to work. That's not going to eliminate anything. So what I need to do is I need to multiply this by 2. Okay? And so I'm going to apply that to all of those, and I'm going to end up with 4x plus 2y equals 8. That's going to cancel out for me. And then I'm going to end up with 5x equals 15. Divide by 5, divide by 5. I'm going to get x equals 3. If you look in your book, they use substitution. They also got x equals 3. I personally like elimination better. It's a little simpler for me to use, but whatever you want to use is fine. I'm going to go back into one of these equations, so I'll just pick this one. So here I have 3, because that's my x right here. So I have 3 minus 2y equals 7. I'm going to move the 3 to the other side, so subtract 3, subtract 3. I'm going to get negative 2y equals 4. Divide both sides by negative 2, and I'm going to get that the y in this case is going to equal negative 2. So x equals 3, y equals negative 2. What did I just find? I found this point right here. So what is that point? That point is 3, negative 2. So 3, comma, negative 2. Now, I did mine. Remember, I just was slapping, like, it's not to scale. It's not right. 3, negative 2 is actually going to be down here somewhere. So my lines aren't matching up. It doesn't matter. I'm just drawing this to help me see, to help me visualize what I'm doing. What matters is these points that I got. Those points are real. My graph is not real. You could draw a real graph. It'd be fine. My graph is just to help me visualize what I'm seeing. All right, so now the last thing that I need to do is I just need to plug into my distance formula. So I have distance equals the square root of, so my x2, and it doesn't matter which one's which. Let's just call this the 1 point, and we'll call this the 2 point. So my x2 is 11 minus my x1 is 3, and that's going to be squared, and that's going to be plus my y. My y2 is going to be 2, and that's going to be minus minus 2. So minus minus 2 is going to be plus 2, and that's also going to be squared. So now I'll just go ahead and solve this out. So 11 minus 3, that's going to equal 8 squared plus 4 squared. 8 squared, 64 plus 16. Add those up, and I am going to get 80. The square root of 80. And this is all still in the square root sign. I have a bad habit of not always writing my square root sign. I remember it's there, but you might not remember that it's there. So make sure you write your square root sign. Now, I need to solve this out. I need to factor this, square factor this. So I'm looking for numbers like 4, 9, 16, 25. I'm looking for square numbers that are going to go into this. What square number goes into this? 16 goes into this 5 times. So I would write 16 and 5. These are still in square root. 16 times 5 is 80. Just in case you're checking, you can always go to your calculator and do that. So 80 divided by 16 equals 5. Okay, so there's my roots. This will come out. This will solve out to a 4. So I would have 4 square root of 5 is my distance between those two. All right, so long process, but things that you know how to do. If you missed anything, always just go back and scroll back and check it out. All right, go over to the next lesson, which is 11.9. I think this is going to be a super easy lesson for you. I think you're going to like it. So 11.9, a straight line equation with a variable in addition to x or y represents what's called a system of lines. What's a system of equations? A system of equations is just a system of lines. Okay, and so all systems of equations, not all of them, but systems of lines that are all going in the same direction are going to have some sort of constant that makes them all the same. Look at these ones. In this case, all of them are parallel, so all of them, the slope is the same in all of them. Okay, look at the next page. Page 227. So how do we find the characteristic that is the same in all of these lines? This is x plus by equals negative 2. The thing that is the same in all of these, okay, is that they all have the x-intercept of negative 2. How do we know that? From the general form, the x-intercept can be found because this is a 1, right? And so when we do that, we divide it because we can't divide the b. Why not? Because that's a variable. We don't know what that is. But the x doesn't have a variable in front of it. So when we put the c over the a, we end up with negative 2 over 1, and we find out that the x-intercept is negative 2, 0. So in other words, this would be a system of lines that all cross the x-axis at negative 2. So in other words, if you look down here, we could have our graph, and we have our point, our x-intercept occurs here at negative 2. And then what we have is we just have a ton of lines going through the same point. This is our system of lines in this case. And you could have actually infinite lines going through that point on the graph. So this system of lines looks like all of these lines going through the point negative 2, 0. All right, let's look at this next one, and then this will be it. In your book, this is on page 227. This is number 1. So we need to determine what's the characteristics of this line, of these lines, okay? Because these are multiple lines. So here's what we have. We have 5x plus 6y equals c. So what we have is we have two different variables on this one, but we have a unknown constant. So what is this one? Here's what this is. This is going to be a family of lines that have the same slope. Because what do we know? We know that we know a equals 5, and we know b equals 6. Well, the one thing that we do know about this is that m equals negative a over b. So we know that all of these lines are going to have negative 5 over 6 slope. In other words, anything that we put in for x equals, whatever, y equals whatever, and c equals whatever. Anything we put in for those variables is not going to change the fact that we have a negative 5 over 6 slope. That's a constant. Why is it a constant? Because our a is 5 and our b is 6. So that won't change. So looking back kind of at your work and the exercises here, what you have to do is you have to go through each one of these, and you have to figure out, okay, for this one, what are the constants? What won't change? So what is the one thing that I see here that's going to be the same for all of these? Go back to the previous lessons, look at the different formulas that we've used, look at how we move things around, and see the ones that are constants, and that will tell you which one is not going to change in that family of lines. Okay? 2 lessons in 1. That's quite a bonus today, right? So I know it's a little bit longer video, but I tried to push those in there just so that you didn't have 2 little short videos on 2 chapters. Okay? And so that finishes up chapter number 11. If you missed anything all the way through that chapter, go back, find the video you missed, and watch it again. Scroll back. Always go back and look, and that will help you learn as you're doing your practice problems. That's all I've got for you, and we'll see you later. You have a good one. Bye-bye.